Hello again. We continue our voyage into ratio problems, and actually, our goal is to be able to create our own problems. And what we're going to do in this video, we are going to consider ratio problems of the type which I called giving money. We have two people, two friends, presumably, who each of them has some amount of money. And then they, so which gives us the definite ratio. And then one borrows from the other, or one gives money to the other. And that changes the ratio, and that's it. Then we create a problem. The only difference from what we were doing before is that the model would change a little, because there, following time, always subtract from the age when you go backwards, and always adds to the age of a person when you go forward. In this case, when you redistribute the money, one gives, the other one gains, and this makes this sign different. But let's begin at the beginning, and let's produce this problem. To control the consistency of your problem in this case, we can start by choosing the whole amount of money. As you see from the table, I have chosen 100, so Jack and Alex, two friends, together they have Jack plus Alex, they have 60 plus 40, which gives me 100. But when I'll be creating the other problem, I'll start with 100, then I'll find the distribution which suits me, like 60-40, and then I'll change it somehow. So what happens here? Jack has 60 pounds or dollars or whatever, euros, and Alex has 40. They are going, for example, to the movies. And ratio now, at the moment when they are deciding to go to the movies, is x to y, 60 to 40, which gives me 3 to 2. And then they want to redistribute their money somehow. And actually, Alex borrows 10 pounds from Jack, which gives Jack finishes with x minus 10, which is 60 minus 10, 50. And he gave this 10 pounds to Alex, and Alex gains 10 pounds, so he has now also 50. So the ratio is 1 to 1 now. If I were solving this problem, let me move this thing a little. If I were solving this problem, I would begin with the table, Jack and Alex. I don't know how much each of them has, so I put x and y. Money now. Ratio now. I know that it is 3 to 2. 3 to 2. Then Jack gives 10 to Alex, which means that Jack now has x minus 1, because he has given that tenner. And Alex ends up with y plus 10. Ratio after exchange, it's x minus 10 over y plus 10, and we know that's 1 to 1, 1 to 1, and that's it. That's the table. I can make it look prettier, but it doesn't contribute to the quality of my solution. So anyway, I'm not sure it contributes to the quality of my video either. Alright, so yeah, the columns should be clear. So my first equation comes from here, and it reads like that. X over y. Now I will avoid this column, and I'll just write my usual representation of fractions. X to y is 3 to 2, 3 over 2. And the second equation comes from here, which gives me x minus small technical x minus 10 over y plus 10 gives me 1 to 1. No, it would be sufficient to write just 1, just for the sake of completeness. Then I start to solve. I crisscross every ratio, and I get from the first I get 2x equals 3y, and from the second I get x minus 10 equals y plus 10. That's it. I can actually the easiest way to solve such systems is just to solve one equation, the easiest one, of course, for one of the variables. For example, I solve the first one for x. It means that I'll have to divide by 2, and which will give me 3 seconds y. And then I plug it instead of x into the second equation. It would be 3 seconds y minus 10 equals y plus 10. And I just solve the second equation. In my wicked ways to solve such equations, I first get rid of this 2 in the denominator, because I don't like denominators. I try to get rid of them as fast as possible. To do that, I multiply both sides of the equation by 2. In this case, I get 3, because 2 cancels 3y. I shouldn't forget to multiply by 2 also 10, so which gives me 20. And multiplication by 2 of the right-hand side gives me, okay, I'll write it carefully, and then I multiply out 3y minus 20 is equal to 2y plus 20. Then I collect all y's to one side, 3y minus 2y minus 20 is 2y minus 2y plus 20, which cancels 2 y's here, and we have like terms here, and y, this gives me 3y minus 2y, it's y. And then I add 20 to both sides of the equation to cancel this 20. Plus 20 is equal to 20 plus 20. And here it cancels. So what I have is an immediate answer. Y is 40. Y equals 40. So, and then I plug it into the equation for x, which gives me 3 seconds times 40, which actually is 3 times 40 over 2, which actually is 3 times 20, which is 60. I knew the answer beforehand, but I wanted to check, I wanted to show you that we really produced a problem which is easy to solve, relatively easy to solve, but on the other hand, this problem is considered to be not very easy for the 7th grade, for the 8th grade still. And so Jack has, I forgot who is, Jack has x, which gives me 60. And Alex has 40 pounds. And that's it. Let us produce another problem of this type. And to do that, I will use the general table I produced in the article, namely this one. It's a universal table, but I don't think it's just when you try doing such things yourself. Actually, it's a good idea to start from scratch, just state the sum which you want to distribute between them. 100 is a good choice. And then, for example, one has, okay, let's take 102, and then let's take okay, let's move it a little bit high here. Let us x plus y be 100 again. This is secret knowledge. We don't reveal it. We don't give it to the people who solve our problem. It's just for our sake, for control. Then, for example, let A be 35 and B be 65. 35 and 65. Let's create names. Let it be again Harry Potter. Harry, and the next person will be Ron. Harry and Ron. But in this case, we're not talking about pounds. They are coins. I don't remember what they were, but they were definitely different. Okay. Just the number of coins, gold coins. So let Harry was richer than Ron, I remember that. And let Harry, okay, let us then change like this. Harry has 65 and Ron has 35. What ratio does it give us? It's money now, ratio now, 65 over 35. 65, 5 divides 65, producing 13. 5 times 13. And the 5 also divides 35, producing 7. So it's 13 to 7. 13 to 7. 7 looks suspiciously. Then what do? I think Harry is generous and he can't give half of his money to Ron. Actually, 65 is a bad number, by the way. It has only 2 factors, 5 and 13. We can say he gives the fifth of his money to Ron, but actually, okay. Let it be 13. I'm not sure that they had 13 as a bad number. let Harry give 10. Harry gives 10 pounds to Ron. 10, 13, that's too elaborate. 10 coins to Ron, and which leaves Harry with 55. But Ron, of course, he gains 10, and this is 45. Exchange. Ratio after exchange. Ratio after exchange. This crooked line should be replaced for the sake of straightness. So finally, rate after exchange is 55 over 45. What can it be? 5 times 11. Oh, 5. 5 times 11, and here is 5 times 9. So this is 11 to 9. We produced a problem. Harry and Ron each has a certain amount of gold coins. The ratio is 13 to 7. Then Harry, being generous, presents Ron with 10 gold coins. Then the ratio of the money they have is 11 to 9. Find how many gold coins they had together in the first place, for example, like that. You can create any type of the problem itself, invent other names, you can take famous people, whatever. But the result is in front of your eyes, and I will try to ask you as a homework to create some problems for me. I will do the same for you without giving you this table, without giving you the answer in advance, just the problem itself. And we will exchange problems, and while you are solving my problems, I will be solving yours. We can have even a test. Depending on what figures you choose, the ratios you get, they can be more difficult than in the first problem we created. For example, this one was, it has very simple ratios. Here, 3 to 2 and 1 to 1, it's much simpler than this one, 13 to 7 and 11 to 9. And the problem will be more difficult to solve, of course. But, on the other hand, the difference is merely technical. And finally, I'd like to stress that it's a good exercise to produce your own problems. You understand the problems of this type better. And the only difference when you redistribute money or other commodities, I don't know, it can be not money, but for example, ammunition for soldiers, forgive me for that analogy, or I don't know, for example, balloons for clowns. Imagine 2 clowns, they have 100 balloons together, they will fly away. But then one clown gives another one some balloons, and they give away balloons to children, and something like that. Something nice is happening. So, anyway, you can redistribute whatever you want. But in the case of redistribution, you have a minus and a plus. Whereas in the first type of problem, with time, you always had minus minus or plus plus if you go forward in time. So see you next time. Bye.